Hello everyone, welcome to Coders Camp. We are at second day of June LeetCode challenge and the problem we are going to cover in this video is interleaving string. Input given here is three string variables s1, s2 and s3 and we have to return true or false if we can form string 3 by interleaving string 1 and string 2. So what does interleaving mean here is like you can concatenate the substrings of A and B or S1 and S2 like in sequential order but any characters from either from S1 or from S2. So let's understand this problem with an example. Consider this example where our S1 is apple, S2 is strawberry and S3 is combination of these two strings. So the given S1 and S2 are this and we have formed S3 by concatenating the substrings from S1 and S2. So now if you see we have APP starting with our substring from S1 and then another substring straw from S2 and then LE from S1 again and then finishing it off with S2. So this can be substring of any length, even a single character and combination of both in sequential order. So how are we going to approach this? So our brute force approach is going to be, we are going to have a result string where we are going to construct all possible concatenation or interleaving of these two input strings. And if any of the combination is matching our S3, then we are going to return true. So how are we going to do that is, we are going to have a variable result in that we are going to construct the string by interleaving these two strings given. So for example, if we are considering a character from our string s1, then in that case we are going to append this to our result and going to consider the rest of the word from s1 and the complete word from s2 for our next concatenation. Same way, if suppose we are considering S from our S2, then in that case we'll append S to that and we will consider the rest of S2 and then the rest of S1 for our rest of the string to be constructed in our result. So this is going to be a recursive process, that is we are going to consider one string and the left will be considered as the second part for concatenation and it will form all possible combination of the words. For example, here it is going to take A from the first word and S from the second word and P from the first word and T from the second word and so on and construct the complete word by considering all the characters in both S1 and S2. Same way it can also be constructed as A, P and then S, T and then goes like P, L and then R, A and so on. Same way it can be n number of combination of these two words S1 and S2 and in this list if any of the combination that matches the S3 then in that case our solution is going to return true. If not, it is going to process all possible combinations and return false. And as this is going to do or construct all possible combination of S1 and S2, it is definitely going to time limit exceed, but we are going to understand the code of this brute force in order to move to an optimal solution, because we are not going to do much of a change. It is going to be the same logic, but we are going to implement memoization in that in order to obtain an optimal solution. So let's go and understand the code for this brute force approach and then come back to the optimal approach. So here is the main method. First, we have to check the basic condition that if S1 plus S2's length matches the S3, then only it is a valid scenario, because we have to consider all the characters from S1 and S2 to construct S3. So we are going to check that first. So the first condition, if it is not equal to S3's length, then straight away we can return false. If not, we are going to call a recursive function. Let us name as inter. Then I'm gonna pass s1 comma 0 comma s2. So here the parameters are nothing but our string 1, string 2 and string 3, and these zeros are nothing but the pointers are index of s1 and index of s2, and here the empty string is our result, which is going to be constructed and compared with our s3. So let's write our isInter function. So here we are checking, as this result is the constructed S3. So we are checking if our result matches our S3 and all the characters in S1 and S2 are also included. So here we check whether our result is equal to S3 and I and J is equal to the length of string 1 and string 2, which means if the indexes are at the last character of S1 and S2, which means we have considered all the characters for constructing our result. So if not, we are going to compute our answer. So first we are checking if our I is less than S1 dot length, which is nothing but we still iterating our string 1. Then in that case, we are going to compute our answer. We are going to call the same function recursively and pass on string 1, comma. If we are considering a character from string 1, then we have to construct our rest of the result by considering the rest of the characters from string 1. So which means if we consider the character at index I, then for the rest of the result, we have to consider from I plus 1. And as we have considered this character from S1, S2 will be the same. So we simply pass J and result will be added with the character as S1. So S1 dot caret I. So yes. If not, we are going to perform the same thing for string 2. That is, if we are considering string 2's character, then in that case, our string 1 is going to be same and string 2 will be from the rest of the string 2 after considering that particular character at index J. So yes, and one more thing we are missing here is this answer actually will be having all possible combinations. So this inter is going to return true or false for all possible combinations. So in that case, if any of the case, for example, your second combination is true, then it is going to compute, still going to compute third and fourth combination. In that case, it is going to become false. So we are going to check if any one of the case is true, then our answer should be true. So we are going to perform an OR operation, which is nothing but even though the next combinations are going to return you false, if any of them are true, then in that case our answer is going to stick with true. So for that we are going to perform OR operation with all the combinations. So finally we are going to return our result. So yes, this is it. Let's run and try. So yes, let's submit, but this is actually gonna time limit exceed. So yes, it is time limit exceeded. So here we are going to optimize the same solution or the same logic using memoization. So our previous solution has been time limit exceeded because it has constructed all possible combination of S1 and S2 interleaving. So here in this approach, we are going to implement memoization to stop concatenating the string if we know that it is not going to be valid anymore. So let's understand very simple logic before understanding where we are implementing memoization. So here consider the first S3. The first S3 is actually constructing APP from string 1 and then straw from string 2, LE from string 1 and then berry from string 2. So in this case, if you have considered apple completely, that is APP first and then straw from the second word and then LE from the first word. So now our pointer I is exactly at the last character of our string 1. So we don't have any other characters left in the string 1 to help us construct our result or S3. So in that case, the rest of the string has to be constructed only by the characters from S2 because we don't have anything left in S1. So in that case, if we have reached I to the end of one string and J at somewhere in the middle of string 2, so we are going to compare the constructed string is actually the first half of our S3 and what is left behind in S3 is what left behind in rest of our string in S2. So if this is matching, then in that case we are going to simply return true. Also consider another S3, which is again the interleaving of string 1 and string 2 given here, which is the formation of AP from our first word and strawberry from our second word and PLE from the first word. So in this case, we have reached our J at the last character in our S2. So what left here is nothing but the rest of the string in our S1. So both of the cases, we are going to return true. Also in our previous approach, we have constructed all possible interleaving of these string 1 and string 2, and then if any of the cases is being true, then we assigned it to our answer. But here we are going to construct our result or S3 only if we know it is going to be matching S3. If not, in halfway, if we know it is not going to construct our S3, then we are not going to proceed with that combination. So here comes the role of memoization. So we are going to maintain a two-dimensional array memo of index I and j. So this is nothing but index of string 1 and index of string 2. So we are going to assign the values like -1 or 0 or 1. So -1 is nothing but we did not cross the index I and j yet. And if we cross or if we reached index I and j of string 1 and 2, in that case we will assign the values 0 and 1. So if so far the string is matching, then we assign 1. If not, we assign 0. For example, let us start constructing A, and again we are taking our I is here and our j is here. So again I'm adding P and again I'm adding P. So in this case, my I is actually going to be at the index 2. Same way, my j is at index 1. So here, memo of 2, 1 is actually formed to the string apps. So in that case, we are going to check if this apps so far is matching till that index I, j. So yes, it is matching apps. Then we are further going to proceed this combination. If not, if it is not matching apps, then we are simply going to drop this and go and try another combination. So again, for example, if it further proceeds with apps and adds L from our string 1, in that case it is going to become appsl and the index is going to be 3, 1. So 3, 1 will be assigned to 0 because our string is not appl, our string is apps. So sorry, apps t, but here apps l has been formed. So in that case, we don't really have to further proceed concatenating the string. So we are assigning 0. But m of 2, 1 would be having 1. In that case, if it is a 1, then we are going to proceed with that combination. So this will actually reduce our time to half because we are not going to form concatenation of every possible string. Instead, we are going to proceed with only the valid ones. So hope you're understanding this approach, and this is actually going to work in big O of m cross n time complexity, where m and n are the length of string 1 and string 2. So let's go to the code now. So here is a code for our approach 2. Again, we have implemented the same logic with a little change. So again, in our main method, we have checked the same basic condition, and if it is not returning false, we are going to call our recursive function with all S1, S2 and S3, and along with that a memoization. So here I have declared a two-dimensional array memo, and I have filled -1 in all indexes. So now here comes our inter method. So here, as I said, I'm gonna check if my I is equal to s1 dot length, that is my index of I reached the last character in my s1. In that case, s2's rest of the string is equal to s3's rest of the string, then we are going to return true. So like k is nothing but here is an extra pointer that points at the index of s3. So if the rest of the string in s3 and rest of the string in s2 matches, then true, if not false. The same way it is applicable to the string 2 as well. If it reached the end of the string 2, then we are going to compare what is left in the string 1 and what is left in string 3 matches. So if it is not, then we are going to check if our memo is greater than -1. Because if we did not cross that index, then it would be having -1. If not, we would have assigned the value 0 or 1. So in that case, we are checking if it is a 1, then it is a true, which means we'll further proceed with that combination. If not, we are simply going to return false. So after all this, if we are proceeding, in that case, we are still constructing our S3 and we are actually working on the positive concatenation. So here we are checking the same logic, that is if the character at S3 match that character at S1, then in that case we are going to consider the character at S1 and we pass on the same values by having I plus 1 and j is going to be the same. If not, if the character at k, I mean like in S3 matches the character at S2, then in that case we're going to consider the character from S2, so j plus 1, but S1 is going to be the same. So it's nothing but the same function we called in our approach 1. So if any of the case matched, then in that case we are going to assign our answer to true. And here comes, if the answer is true, then we are going to assign 1, which means it is a positive concatenation. We can further proceed. If not, if the answer is false, then in that case we are going to assign it with 0. Finally, return what is in the answer. So this is it. Hope you're understanding this approach. Let me run and try. Yes, so let's submit. Yes, the solution is accepted and runs in 1 millisecond. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.